So we're going to focus on the profit diagram one day after the market maker sold this call. So imagine that the market maker sold this call yesterday, received the $2.78, and is looking at the profit and loss as of today, one day later. And that's the solid color graph here. And we can see that if the stock price remains at 40, that the net profit to the market maker is 0. The implication of that is that the market maker is long the $2.78 received and short a call option that's effectively worth the same amount. So the profit at the moment is 0 if the stock has not moved. There would be, of course, a small theta profit that the manager, the market maker, would earn because the value of the option is diminishing, and therefore there would be a small theta profit. But let's ignore that. What we want to focus on is a day later how much risk the manager has if the stock price moved. So we have, this is the position of the market maker, and imagine that the stock price moved up to $45 or moved down to $35. So at this point in time, if the manager does not do any hedging, we can see a substantial amount of risk, namely that if the stock doesn't move, the manager is in a net 0 position, the long cash and the short call are about the same. But if the stock price goes up to 45, an increase of $5, we see that the manager is now in a net loss position of $5. The call option increases in value about $5, and that now, of course, puts the manager in the red, because the manager has $2.78 on the long side, the asset side, and a liability of an option which is now worth roughly $7.78. Conversely, if the stock price dropped to $35, the manager would see an immediate profit of about $2, say, and that's because with that drop in stock price, the call option would drop from $2.78, it would only now be worth, say, about 78 cents, and the manager would have a profit of $2. So that's the risk that the market maker is worrying about, and it wants to contemplate hedging. That risk is a delta risk, because what is delta? Let's recall delta. Delta is related to the slope of the curve. Recall that delta is, by definition, the derivative of the option price with respect to stock price. Now, this is a short option, so we need to put a negative in front of that. But the delta is effectively the slope of the tangent line to the price at 40. So when the manager sold, when the market maker sold this option, the price of the stock was $40, and the manager could figure out the delta position, and the delta is the slope of the tangent line to this curve. And we see that the delta of the call is 0.58. Now the market maker's delta is negative. We saw that on the graph. There was a negative slope on that line. So it's the investor who has the positive 58. The market maker has a negative 58. And we can do the math that, well, how does delta work? If we have a 75-cent increase in the stock price, the option value ought to increase by about 0.58% of 75 cents, which is around 44 cents. Now, the actual increase in the option is going to be a little bit different. So again, if we quickly look back at that graph, what delta tells you is how much the price moved on the tangent line, and we can in fact see that the price of the option goes up. Remember, from the long position, we're going to flip this graph so that it's increasing rather than decreasing. What we would see is that when the price of the stock goes up, the value of the option goes up by more than what the delta approximation says. And when the stock price goes down, the value of the option goes down by less. It's below the tangent line. And the reason is gamma. Gamma reflects the change in delta. And what we would observe if we look carefully at that graph, because of its convexity, is the fact that when stock prices move, delta goes up. That curve, if one looks at, again, flip it so that it looks like the call position to the buyer. If you look at it from the call position to the buyer, where it's now an increasing curve, you'll note that the slope of that curve increases when stock prices go up, and it decreases when stock prices go down. So if we're trying to estimate what happens to the call price using the delta at a strike of 40, what happens? When stock prices go up, that delta is really a little bit too small to estimate the call price change, because delta is increasing as the stock price goes up. Similarly, when the stock price goes down, what we have is that the delta approximation overstates how much the call will drop, because as stock prices go down, the call delta will in fact get smaller. And this is what gamma measures. Gamma reflects the change in delta, and a call option has a positive gamma, which means that when stock prices go up, delta increases, and when stock prices go down, delta decreases. So here's a picture of the graph, if you will. This you could think of as the profit and loss to the buyer, the investor. The investor initially paid $2.78. So if the investor gets no payoff from this option, there'll just simply be a negative $2.78 loss. And so here it's a little bit easier to see the point I was making about delta. Delta is the slope of this line. And what we can see is that as stock prices move to the right, this is increasing S, we can see that the slope of the curve increases, so that delta understates the effect of stock price moves. Similarly, when stock prices move to the left, which is to decrease, we see that the delta, the slope of this line gets more shallow, and therefore delta at a 40 strike overstates how much the price will change.